Good evening, everyone. I am your host and instructor, Laney Shaughnessy, and welcome to Spindle TV, your best source for CNC CAD/CAM training videos. Spindle TV is brought to you by Digital Woodcarver, inspiring your creativity and providing you with the tools to create your own unique masterpieces. Good evening, everyone. I am your host and instructor, Laney Shaughnessy, and welcome to Spindle TV. If y'all were hearing double there for a moment, I forgot I had the preview playing in the background, so because of the delay, it was coming up twice. Excuse the mess in the background. Been doing some office redecorating, so I got everything thrown up on the bench behind me. How are y'all doing tonight? Hopefully you're doing well, and hopefully things are going good. Hopefully you can hear me clearly, see me, and all that wonderful stuff. All right. But yeah, I do need to shave. Yeah, man. Working on it. One of these days I'll have time to get rid of this gray hair and shave up a little bit. Get my face to looking normal again. So tonight, someone had asked if we could look at making boxes in the Vectric software on the CNC period. And so we're going to do that. We're going to look at making boxes. We're going to cover things like the box creator gadget that the Vectric software offers. We're going to look at the Dovetail gadget that the Vectric software offers, and we're going to look at just creating our own boxes and shapes and things, whether it's a two-sided project or a one-sided project that we're going to take over and finish up the joinery on the table saw or something. We're going to look at a lot of different aspects of box making and all. And then we're going to kind of discuss, options and stuff. One of the boxes that let me see if I can reach back here. One of the boxes that I enjoy making are like Kleenex cover boxes, for tissue boxes and things, covers for those. And so we're going to look at making one of these covers this evening, and kind of go from there. It all depends on, as far as the size of the box and everything, depends on the size of, the Kleenex box and all. But we're going to look at a couple of things, and I think it'll be an informative class, and maybe give you guys and girls a look at ways of doing some cool boxes, jewelry boxes, gift boxes. They can be square, they can be round. How to look at or address hinges and things. So we'll go. We'll kind of. We'll try to cover not a lot that's going to overwhelm you, but just enough to give you the information you need for just different aspects of joinery and things like that, because we have half lap joints, we've got butt joints, we've got miter joints, we've got things like that. I'm going to show you how to cut. It's basically a chamfer but a miter, using your 90-degree V-bit. We'll use that when we're working on the tissue box and stuff. But with that being said, that long introduction, let's kind of jump into the Vectric software, and we'll get started. All right, so here we go. Now, in the Vectric software, I want to talk to you about some of the free projects that are out there on the Vectric site, which are great tutorial projects for learning box making and learning also two-sided machining. And different things. What you see on the screen now is basically one of the free projects from Vectric, one of the Cool Cubes boxes, and it's just basically a demonstration on two-sided machining. And for the concept of two-sided machining, because with most boxes, a lot of them, not all of them, but a lot of them will involve two-sided machining, to the effect that we're going to have our decorative side, and then of course on the back side we're going to have our vectors for our joinery and things. And a lot of people are still kind of struggling with the two-sided machining setup, flipping their board and things like that. And I will tell you, one of the most useful aspects when you are doing two-sided machining is alignment pins. But one of the procedures for your alignment pins is a little easier than the other, because it allows you to maybe carve one side of the project that day, and then if you have to move on to something else, maybe something last minute comes up and you got to change over, you want to be able to come back to finish up this box that you started the front side. And we want to be able to just very easily mill our alignment pins and our waste board, stick them in, and then flip this board over and land exactly where we need to be to set up. And so I want to discuss that a little bit as we go. As we're looking, let's kind of switch over to our drawing side here. What we're looking at, let's go to the bottom side, which in this sense would be the top. But our face, in this example, we have our front panel, which is this second box here, our rear panel, one of the sides and the other sides, and then the bigger box is the top. And right now this top just basically sits on top of the cube, whether you attach it with rare earth magnets, or maybe create a little pocket to fit inside where it kind of has like a little lip. We'll talk about that. But generally, when you're carving and all, generally you start with your joinery. And that's why they have in the Vectric software, that's why they have this set up as the top side. Because you're usually cutting your joints and everything off the back, and then you're flipping it over and doing all your decorative carving last, which would be the face of this particular box. But let's look at the job setup first off, and let's kind of go over what it is. And I want the individuals that have Vectric 8, 8.5 or earlier versions, you don't have the option of two-sided machining that became available in the version 9 software. So basically, you guys that have the earlier versions would have two separate files, two separate Vectric files. One would have all of your back, geometry, which would basically be the joinery, and then the other file would have all of your decorative face, the front side of the boards. And you would still set them up and mill them the same way. It's just you're working out of two separate files versus being able to do it in one file that has the two-sided operation. And we're going to kind of talk about that, and I'll explain that process. But let's look at in the version 9, let's look at the job setup. So of course, we have it set up as a two-sided job, meaning that we're going to carve one side, then we're going to flip the board over and carve the other side. Now, in this Cool Cube example, that's a free project and tutorial in the Vectric library, the material itself is set up as 24 inches in length. It's about 5.5 inches wide and a 1/2 inch thick. So it's ½ inch basically is going to be the walls of the box, Now, the Z0 position, this is where, this is what kind of throws people off sometime, is the Z0 position, setting up your zeros and all. And in the There's no right or wrong way to do this. You can have it to where you are touching off on the top surface of the front side, and then when the board flips over, the bottom side, you're touching off on the top surface as well. You can set it up to where you're working off of your machine bed or your waste board if you're cutting these parts out and things, where you're touching off to that. But you also have the ability to work off the same surface, and this generally is a really good way to go, especially if dimensions and size matter. So what I would generally do is on my box part, let's say this is my 24-inch by 5.5-inch box part, the first thing that I'm going to do is I'm going to actually face plane the board to just take a small amount of material off, make sure that it's nice and even. That way I have a nice even surface to reference off of when I flip this over. After I face plane the board, then I'm going to, after that face planing operation, which is a completely separate operation than the box making, it's just preparing the wood. After I face plane it, then when I touch off to that surface, that's going to be my known flat surface. And when I flip this board over, then that surface is going to be on top of my waste board, right? It's going to be facing down. So for the second setup, the second touch off for that second side, I'm going to actually be touching off on the waste board rather than the top of the surface. That way I'm always referencing off the same face of the board, and that way I'm referencing off that nice surface, and dimensionally we're gonna everything will be more accurate. But again, there's no right or wrong way to do this. You can reference off the same face as this example is here set up now, or you can reference off just the top of the boards on both sides, or off the bottom of the boards off both sides, however you want to set it up. I just because just in case my milling process and all and my board is just a little thicker than 3/4 of an inch or what have you, I like referencing off the same face, so it's referencing that 3/4 from that face, 3/4 thick and all, or 1/2 inch in this case. So however you set your Z position up, just remember that when you're at the machine, that if in my case I have to remember that I'm touching off on the top of the board for that first part, but when I flip that board over, I got to remind myself to touch off to my waste board and all. And that is important to remember, because if I touch off on the top surface, then I'm kind of carving in the air for that second time around. Now, as far as the XY datum position, you can start from the center, you can start from the bottom left corner, top right corner, anywhere you want to start from. In a two-sided project, I like to start off the bottom left corner for the simple fact that I'm going to be using alignment pins, and most likely I would be just in case my, let's see, how can I explain this? The bottom left corner is just a good place for me to start, because one, if I have a choice, even though that I've got my toolpaths for my alignment pins, I could also use my wedge jig, which references off the bottom left corner, if I wanted to just use the wedge jig to hold my material. Now, but again, we can start off the center for our XY if you want to, but I've got this set up for the bottom left. Now when it comes to that jig, if I do want to reference off that jig, I've got to be absolutely positive that my face or my fence of my jig is true, my 90 degrees, because when this flips over, then that top side here is going to become that bottom left corner, and so I want to make sure that they end up in the same position. For me, if I'm not using the jig, the alignment pins are the most accurate way to work this. And so you kind of have a choice. You can work off a 90-degree jig, which is something like the wedge jig, or you can use your alignment pins. I'm going to talk about the alignment pins. I don't want to bring the jig into the mix. I just wanted to explain to you why I've got it set to the bottom left corner for myself, is because I have an option of either or, depending on what I want to do. But I want to focus on the alignment pins because that's where people tend to struggle. And so we are going to reference off the bottom left corner for our XY0. This allows me to use my XY touch block to set my first, XY0 position, my quick set block, my DWC quick set. It allows me to use that to give me a really accurate, and I'm not trying to eyeball the center, even though I do have the laser guide. Some of us don't. You know what I mean? You don't have the laser guide. You might not have your XY touch block, so you're kind of eyeballing, and you really need to make sure that you get that center, that bit, over your start point, whether it's the center or the bottom left corner. It's very important, in your setup and stuff. Now, for my flip direction, in my case, you can flip the board end to end, right, long ways along that x-axis, which is what's kind of defaulted here, or you can flip it along the y direction, where you just flip it from bottom top, just kind of flip it over in this direction here, basically like the arrows indicating here. Well, it doesn't matter which way you're flipping it. It's in the setup in version 9, because it will mirror those parts accordingly from the front to back. It'll mirror the parts appropriately based on the flip direction that you choose. But if you have the earlier versions, 8, 8.5 and things like that, then you absolutely need to know which direction you're going to be flipping this board, because you have to physically mirror these parts, in that new project. You have to mirror them appropriately so they match up. It's important, because if I flip everything left to right, along that 24 inches, then my big box top over here, when I flip it over, is going to end up over here. If I flip Y direction, side to side, on this short 5.5 inch area, if I flip in that direction, then everything is going to be in its same place, but it's going to be mirrored. The top becomes the bottom and the bottom becomes the top. So we have to know how to mirror that part properly in the older versions of the software. The V9 does that for us. It already figures that out for us based on what we choose. And so a very straightforward, even though I talk a lot and make it confusing, double-sided job, 24 inches by 5.5 by a half inch thick. I will be referencing off the same face, meaning I'm touching off on the top for the first part. When I flip it over, I'm touching off on my wasteboard for the second cut. I'm working off the bottom left corner. It allows me to use my DWC quickset tool, and I will be flipping it along the Y direction. Now when I do that, it's going to ask me, because this particular project comes with bear with me a second. I don't know why my part's mirrored. Oh, they got drawn backwards because they when they drew the... Okay. Everything's over here now on the right side. But it still stays on the right side no matter which way I flip it. It's still on that side. But the way they had it designed in the tutorial, they were flipping along the long direction. So sorry about that confusion. Now, the... 9 times out of 10, you're always doing your joinery first, if there is going to be any joinery that you're carving. I could just be carving my 4 sides of my box, my 2 sides, my front and back, whatever it may be, and my top lid and everything. I could just be doing a decorative carving, and when they're done, I could be taking them over to my table saw and cutting miters on each of the edges so I can miter joint this, box together. In this case, they're using a basically rabbet joinery to connect all four sides, and so that's what these vectors are here. These are the vectors for cutting out the rabbets and stuff. So if we look at the toolpath and the preview and everything, let's preview all the sides. If it'll show us. Oh, I got the tool turned off. Dadgummit. I had the tool turned off. Alright, let's flip this over. Alright, so basically those vectors are for the rabbet joints. You've got your joints on the side, then you've got your groove going across the bottom for the bottom panel that's going to fit in the box and everything. And so therefore, let this flip over properly. There we go. That way we can see the nice colors and stuff. You've got these nice rabbet joints, and then of course when the part gets cut out, there are tabs holding them in, but you have your joints for these boxes to fit together and everything. And a lot of times I do use the rabbet joinery, especially the bottom groove for the bottom panel and stuff. But there's a lot of times I like to do miter cuts. I like miter edged boxes because I use miter splines and things like that. And all of that stuff is generally done at the table saw. But I'm going to show you when we get into the tissue box, I'm going to show you how to create that chamfer or that miter using a 90-degree V-bit for the top and the sides of the tissue box, parts and things. But generally you're pretty safe with doing joinery such as rabbet joints. The only thing about the rabbet joints is you got to make sure that from your front panels and side panels that when this is all glued together that you're not seeing end grain. I don't mind about seeing side grain in my boxes and things, but I don't like seeing end grain, because if I'm staining my box, if I'm painting it or what have you, that end grain generally with stain and all is going to come out a lot darker than the rest of the box because it's just soaking up so much more of it and all. So we want to make sure that we get our joinery right, that when this goes together that all of the joints that we're either seeing side grain or no grain at all, like if it was a miter joint. So how many of you have I lost so far in all this long explanation? It should be pretty easy, but you guys, I'm assuming that a lot of you have some kind of woodworking background. So you're very familiar with a rabbet joint. If you're not, a rabbet joint is basically an edge cut. A rabbet joint, let's go into the 2D view, and let's assume that one of these rectangles are bored here. We're looking at it from the top down. And we are cutting a groove out of that box so that we create what's called a rabbet. And that allows another part to fit into that rabbet for the joinery. And let's see if I can actually size this appropriately. And so it allows those two parts to fit together. And so that edge groove is called a rabbet. Now, the bottom groove is, you've got when the cut goes with the grain and it's not on the edge, it's kind of in the middle of the field. Okay, that's a groove. And if it were going against the grain, that's a dado. Okay, so dados and grooves. Basically, let's see if I can draw this out. Let's imagine this is the end cap looking long ways down the board going with the grain. and we create that groove. Okay, and let's imagine this is the how can I draw this out? Bear with me a second. If that's looking down, let's imagine can we imagine? We can. Let's imagine this is going against the grain. Which they both look alike when you're looking from the side. So, you've got dados and grooves. Groove goes with the grain, dado goes against it. And then you have your rabbet, which is on the edge of the board. Okay. A miter cut. We'll use, let's come over here. A miter cut is a generally 45 degrees, 45 degree angle, and it usually does not have a step down like that, so bear with me a second. Let me get over there. There we go. A miter cut is usually typically a 45 degree angle, and typically it is generally not leaving a long straight lip like this. It is typically coming, let's see if I can do this again properly. Get back to my 45. There you go. And a miter cut allows for the part, let's see if I can Control C, Control V to copy that, and if I can flip it, or wrong way. Why did it flip that way? Flip vertically. There we go. And stand by. This will make sense in a second. Let's rotate. Let's pull that pivot point here and then rotate 45 degrees off that point all the way around. There we go. And then let's move this down to here. So a miter cut is basically two 45 degree cuts that allow those parts to fit together. So that's your, then you have dovetails and you have finger joints and things like that. But for your common joinery, you've got your miter cut, dados, grooves, rabbets. You have butt joints where there's no cuts at all. They're just two ends of the boards just butt up together and things. We'll get into the dovetails and the finger joints here in a moment, but I want to talk to you about the common joinery because in our example here, we are using those rabbet joints. So we've got the rabbets on the side, and then of course we've got our dados down here on the bottom, and they're a dado because they're going against the grain. They are for the bottom panel, the little bottom square piece that's going to get put in there. Now, if you notice, that square piece is not in this project whatsoever because generally you're cutting out a square on your table saw, your miter saw, whatever the case may be. You can use your CNC to cut out that part as well. But in this case, this is assuming that, this tutorial, they're assuming that you have other means of cutting out a square part and not a CNC. So with all of that being said, let's talk about some of the tools that are available to us in the Vectric software. And one of those tools is the box creator gadget. So let's imagine that I have an 18 by 18 inch piece here that is 3/4 of an inch thick, 1/2 inch thick, whatever you want the thickness is. It's going to be a single-sided job. I'm actually going to do all of this one side. We're not going to do any decorative carving. We're just going to make a box, a plain, simple box. Then we'll talk about the double-sided stuff here in a moment. But I'm just going to make a very simple box, no carvings or anything decorative and all. I will be touching off on the material surface, and in this case, I'll reference off the center. That's fine, or off the bottom left corner, whichever one. Just depends on what I feel like, if I'm using my DWC Quickset or if I'm just going to use my laser guide or whatever the case may be. But we'll work off the center. And with this set up, now you have gadgets like the Dovetail Creator. You have gadgets like the Box Creator. You have different things that you can do. Well, we're going to use the Box Creator gadget. And for you guys and girls that don't have access to gadgets, because you have Vectric VCarve Desktop, bear with me for a moment. We're going to get into making boxes without using gadgets, but I just want to talk about this because it is a gadget that is available out there. So in the Box Creator, you have to set up your job, your work area, and then we can come in and open up the Box Creator tool. Now hopefully let me see here if it'll even show it. Yep, good. I was about to say hopefully my presenter will show the Box Creator area. Now with the Box Creator, we set up basically our geometry of our boxes. How big of our sides, what's the length of our box, what's the height of our box, what's the depth of it, the joint width, how wide do we want the joints to be. And with the Box Creator, they have basically two types of joinery that they're doing: square tabs, finger joints, or dovetails. Okay, so let's say that my box is a let's see here, let's go 10 inches in length, 5.5 inches wide, which would be the depth, and then it's going to have a overall height of 5 3/4. My joints in here, I don't want a lot of finger joints or a lot of dovetails and all, so I'm actually going to stick with the 1.5 inches. We'll stick with that, and I'm going to leave the allowance at 0. Now faces to machine. Okay, so I want to make the lid, the bottom, side 1, 2, end 1, and end 2. Well, in this case, I'm not going to make the bottom because I'm going to take that over to my table saw and just cut out my square bottom and things. So I'm going to make the lid. I'm going to make side 1 and 2 and then make my 2 end pieces. I'm going to select my tool. And for this tool, I'm going to use an 1/8 inch end mill, because especially if I'm doing a dovetail joint, I'm going to use my 1/8 inch end mill versus my 1/4 inch end mill. And so I'm going to come down to my 1/8 inch end mill. And for the joint type, we'll start off with the square joints to begin with, the square finger joints, the square tabs and all. Now the lid, I can have a tab lid, like literally it fits into finger joints as well as the rest of the sides, or just a flat lid because I'm going to use hinges or something. And in this case, I'm going to use a flat lid because I'm most likely going to make hinges, put hinges on there. And I'll show you how to do the vectors for the mortises of those hinges and stuff. So with that, we're going to click OK, and it's going to create my box parts and all. And so with those parts, we're going to go ahead and we're going to center them onto our workpiece. And then on the Toolpath, it actually, through the whole thing, it actually made the parts and calculated the toolpaths all in one go. So I'm basically just going to recalculate the toolpaths where the new joinery is. And literally, that's all I had to do to be able to make this box. It created the toolpaths and everything for me. But let's machine these parts out and let's take a look, because the one thing it doesn't show in here, it doesn't show the dog bone fillet, but it does show the path where the bit is going to actually go in to create that fillet. So let's go ahead and preview this. Okay, and let's zoom in real tight to this, because I want you to see the dog bone fillets. Even though you didn't actually see them in the actual vectors, they were created by the toolpath, by that gadget. They were created for you. The dog bone fillets are so the router bit on inside corners has a place to go, so it creates that square point so that our male tenons, and I guess our fingers, will be able to fit into those female areas, and we won't have radiuses here. So it created all those for us. Now on the box lid, it created the lip. So it actually created the lip, and let's go ahead and I'm going to recalculate this toolpath. It put the tabs in and everything for me, but I'm going to take the tabs out of the equation for a minute, so that way I can remove the waste material so you can see the parts. And so my lid, it pocketed it out, so it creates that lip that goes, it slides inside the inner dimensions of the box and all. And so the box making gadget is for quick and simple, box making and stuff. Now as far as the bottom, right, as far as the bottom part, because I did not make the bottom, it didn't make any kind of grooves or anything in these parts for the bottom. But let's go ahead and go back and revisit that. Let's delete this and delete these two toolpaths. And let's go back into that box creator, and this time let's actually make the bottom piece as well. Okay, same square tabs, same flat lid, same tool, same dimensions and everything. We're just going to include that bottom part in there. And so now our bottom piece, they made it with finger joints as well. So no rabbets, no dados, no grooves or anything. They made that part, that's this part here, so that the walls and all snap into one another. So they basically created a finger joint, bottom groove. And so you have the option of making the part with or without. In my case, I would probably generally, because I wouldn't want the finger joints at the bottom like they are, so I would generally have well, I mean, I could do that, but on my parts I would generally not have the bottom being finger jointed like this. So in my case, this piece would be gone. Let's turn off the toolpaths for a moment. Now, the only problem with that is the bottom parts of my project have those fingers on them. Those fingers and notches, thinking that the bottom piece is going to be notched out. Well, I don't want that. So what I would do is, first thing is, let me get this centered up on our material. And let me get these parts moved around so everything fits all nice and pretty. All right. Well, on my joinery, in the case of my joinery, I don't need these bottom tabs. This is supposed to be snapping into a bottom piece that I'm not using. I'm using a rabbet, or a groove. So what I need to do in my case is I need to come in and on these parts here, I got to first ungroup them. Bear with me a second. I need to cut these vectors. So I got to cut all of these little tabs off, basically. So I got to come through and cut. And with those cut on that first part, let's turn off this toolpath. On that first part, I'm going to be removing them, and I'm going to be joining them with a straight line. Okay, going to be joining them with a straight line. Now the vector that you see here, this outer vector and everything, this is kind of like the path of, the tool path and things and stuff. Well, I'm going to basically be recalculating a toolpath, so I'm going to get rid of that. And same thing here, I'm going to get rid of that one, and that one. And I've got to go through and cut off those bottom tabs. Cut the vector, get rid of it, and then join this with a straight line. The join with a straight line tool is the second icon on the last row of the Edit Objects menu. Got two more to do, and I'm going to do both of these at the same time, and then we'll come and trim them away and join them. So we're going to cut the vector in these two spots here, here, and here. And then on this one, we're going to cut the vector here. And so those three parts I can go ahead and delete, and then I can join with a straight line and join with a straight line. Now I have all four parts that are going to fit together with this one finger joint because of that 1.5 inch, spacing. Basically a single finger on my 5.5 inch wide boards. But now I got to create the area for my bottom panel to fit into. And so what I'm going to end up doing is when these parts come together, there's going to be a groove. Basically a rabbet all the way around on all four sides. So I've got to draw in that rectangle. And so my piece, when I draw that rectangle in, my parts are a 1/2 inch thick, right? But how big is my bottom panel? My bottom piece isn't going to be a 1/2 inch thick. I'm most likely going to use like a 1/4 inch piece of plywood or something, maybe solid wood. But in my general cases, all my boxes are like, birch or oak plywood. So it's gonna have a thickness or a height of basically 1/4 inch, kind of representing, that part. And then the rabbet, let's get that I'm gonna snap that here, and let me find my center and snap it in. Now, same thing, let me go ahead and draw all four of these. Right now I'm not concerned about the length, I'm just concerned about the height because that's my 1/4 inch. I'm just drawing out basically kind of like a mock-up of the panel. Alright, now for these, I'm going to go ahead and use my alignment tool. Might as well since I have it. I'm going to select on this groove. I'm going to select on my part. I'm going to align it centrally and then to the bottom edge. Okay? Align it centrally to the bottom edge. Same thing with this one. I'm going to select this one and then my part. Align it centrally and then the bottom edge. The next one. Select my part. centrally, bottom edge, and then the next part centrally and bottom edge. Now, this, I don't need to be that long. I don't need it going past the material that much. There we go. Now this is basically a representation of my bottom panel. Well, my bottom panel is going to fit into that this rabbet that's going to be cut out of the main part here. So I need my router bit to make sure that this edge is flat. And right now, if I take, this is a 1/4 inch tall, so let's imagine I'm using a 1/4 inch end mill. In my case, I'd most likely be using an 1/8 inch end mill, but let's say I'm using a 1/4 inch end mill, and let me draw in my 1/4 inch diameter. Well, when it's going to cut this groove, you know, along here, it's going to be leaving a little bit of fuzz on this edge. It's not going to mill this outer edge very cleanly because it's only able to carve in between the lines. And so therefore, not only do I want the bit to be able to go past my part, that's why these vectors are extended beyond the part, is so the bit can go past it to create that nice sharp corner here, but I also want it to be able to do that along the edge. So I'm going to make my part, I'm going to bring it down just a little bit past that edge. So now when my bit comes and, oops, hold on, wrong one. Boom. Let me get that back where it belongs. Not only has my bit going to be able to mill that nice clean lip for that rabbet, but it's going to be able to move over and clear up that outer edge and things. So we want our vectors for our rabbets to not only extend beyond the part left to right, but also beyond the part to the bottom. So on this one, we're going to pull this down a little bit. How far you pull it down just depends on how far you want the bit to go past that part. Normally you don't need to go very much. And so now with that, we're going to create the pocket toolpath for these parts, these 4 vectors, these 4 rabbets. So our pocket toolpath, how far do I want them to go in? So my material, my sides, my front, back, and sides is a 1/2 inch thick. I generally go about a 1/4 inch, half that distance. Okay, so that's going to be my cut depth, 1/4 inch. Okay, my bit I'm going to be using is a 1/4 inch end mill. And this is going to, we'll just call this our rabbet pockets, R-A-B-B-E-T. And we're going to calculate those. Okay. Now on the cutout, because I got rid of that outer perimeter, that had the vector going inward for that inward cut, I actually have to create my dog bone fillets. They're no longer there. So I have to come into my fillet tool, which is the first icon on the 3rd row. And I'm using, I'll go ahead and stay with my 1/4 inch end mill. So I need an 1/8 inch fillet on these inside corners. Oops, not a normal fillet, a dog bone fillet. So on all of my inside corners, I need to create those fillets. And now on my cutout, I'm going to go ahead and recalculate that toolpath. And now let's preview all of these toolpaths. So the first of the toolpaths is going to be the pocket cut. Actually, they're making it the last one for some odd reason. Let me see where my pocket cut didn't get cut out. Let's find out why. Okay, so we'll recalculate that. There we go. Let's get that pocket to cut out. Okay, so again, dadgummit. Hold on a second. My tabs were still connected to the my tabs were still connected to the lid. Let me reset that. Let me go back into the cutout and turn those tabs off. There we go. Because I want to be able to kind of remove the waste material so you can see. Okay. So now as we zoom in, you can see the rabbit cuts for all four parts and everything for the joints, you know, for the bottom panel to go into and everything. The bottom panel, I'm generally going to cut that out on just a square. It's just a square piece of you know, 1/4 inch material. I'm going to cut that out on the table saw. If I was going to use my CNC, then I need to know what my inside dimension is, right? And I can steal that from, you know, the lid. This would be the inside dimension of my box. And then I need to add in the length and width of, and let's make a copy of this. It's not going to have enough room on my board to cut it out, but now my rabbits, they're 1/4 inch deep, right? So I need to make this 1/4 inch, which is a total of a 1/2 inch I got to add to the length, and a 1/2 inch I got to add to the width, so that it's the size of these, you know, these rabbits that are in the bottom of the part. So if I open up my size here, I've got the X and Y linked. So if I change one, I should be able to change this to 9, and it not wanting to change the aspect ratio. So I'm going to unlink this, and this is actually going to be, oops, one more time. I'm going to change this one to 9, adding that 1/2 inch to it, and I'm going to change this one to 4.5. And that's going to give me that bottom panel. It won't fit on this board anywhere to cut it out, so I'd have to cut it out of a separate board or something, or make my board longer than 18 inches, make it, you know, another like 22 inches or something. Either way, so all the parts can get cut out of it. So long story short, we can use the box creator to actually create our entire box, joinery, toolpaths, everything. Bam. Or we can utilize it to get the vectors and all laid out, and then we can come in and modify for our own specific needs. Now, if I was doing this without the box creator because I had desktop software and everything, then basically I've got to figure out what my joinery is and how I want it to fit together, and I got to draw those shapes out. You know, I've got to draw those shapes out and then create the joints on how it's going to fit together. So you just have to do, you know, that work. And it's not, even if you have Aspire or if you have Pro and you're building your own box, you've got to know how your box is going to assemble together. And speaking of that, let's go ahead and make our tissue box, because we're going to make this from scratch. So for this tissue box, we're going to go ahead and I'm going to still use my 18 inch by 18 inch piece. Now, the tissue box that I'm going to be using is going to be the flat square. Let's see if I can switch over to my camera here for a moment. This is going to be the flat square box, and this box has a dimension of 9.5 inches in length. If I'm not mistaken, it's about 2 1/4. I'll have to get my tape measure out in a minute. And 4 3/4 inches wide. So that's the tissue box dimensions. We got to make sure that our cover, our box, fits over this tissue box. So let's go back to our Vectric. And before we do, let's pause for a minute before we get into this and let's answer some questions. So John McMillan asked, is there a way to add the gadget into Pro 8.5 or will it upgrade to 9? So John, your gadget, the gadgets, you have Pro, so you have access to the gadgets. And how you add a gadget is you're going to go online. You're going to go online and you're going to go to Vectric.com, downloads, and click on gadgets. In the gadget library, access the gadget library. And in the gadget library, we have gadgets like the box creator, dovetail gadget, dog bone fillet creator, chamfer gadget. That's another one. We're going to use that in a moment with the tissue box and stuff. But the box creator gadget, you basically click on read more / download. It's available for Pro and Aspire. And you scroll all the way down and you click download gadget. When it's downloads, you then run that gadget and it will add it to your list in your Vectric software. That's all you got to do is just click that download gadget. When it downloads, you can then run the gadget. Okay, that's how you add the gadget. And once you do that, then you will see it in your... Sorry, my dog is coming in here. It will add it to the list. So for me, the gadgets I've added for class is the box creator, the chamfer gadget, and the dovetail creator, which has our pin and our tail creator. We'll talk about that in a moment. And so for this tissue box, we're going to use the chamfer gadget, or we're just going to show you how to create the vectors to use your 90-degree V-bit. Either or. And with that being said, let's kind of look at this tissue box. So this tissue box is mitered. It's a mitered box, and all except for the bottom panel. The bottom panel is a square panel, but all of the sides, the two sides, and the top of each part is mitered. So for our side walls, the two sides of the board and the top, they are 45-degree mitered, and our lid is mitered on all 4 edges. Okay, so that way when this part fits together, see if I can back up a little bit. When this part fits together, all the corners are mitered. Seams virtually just disappear, and then our lid with its 4 mitered corners comes in and sits down into that top. And then in the top of the box, we're going to have an oval, but we would have a access, for the tissues to come out. On the bottom, well, we've got to have a way for the tissue box to get in there, right? We can't be gluing the bottom panel and everything in. So what's going to end up happening is there's going to be basically one of the side pieces is going to be two separate parts. And what I mean by that is, let's see if I can get one of these parts to move out. And let's see if I can really quickly cut this bottom piece off here. Alright, draw a line straight across there to there. On the back side, same thing. Draw a line from there to there. And then on the sides, draw a line there. Let me see if I can spin around. So now oops. Bear with me a second, ladies and gentlemen. I need to make these parts unique. Because if I do something to one, it does it to the other. Alright, so we're going to have a bottom piece. Let me get rid of these guides so they don't confuse the situation. And this bottom part is going to have a rabbit rabbit on it. And then we're going to have our upper piece, which is going to be glued to the rest of the box. Let me get rid of okay. So one part, bear with me a second, I got one more line hiding right there. Oh, you son of a gun. Hold on a second. Get back there. Okay. So the box is going to be all glued and assembled together except for the bottom part here. Let's get rid of this for a moment. The draw window in the SketchUp software is so slow, so bear with me a moment. It's got to select all those parts. There we go. So when my, oops, come on now. When my bottom panel slides out, the box opens up, and I'm trying to stay on my axis here. When the bottom panel slides out, the box opens up and allows me to, insert the tissue box, and then it slides back in. Hopefully you guys get that. But anyway, one of the side panels has basically a bottom part that's attached to the bottom piece of wood. And so to open the box up, you slide that out, put the tissue box inside, and then close that bottom part and all. And so hopefully you kind of get that. And then, of course, we have our hole in the top. So this is the box we're going to be making in the Vectric software from scratch. Okay, so John McMillan, hopefully that answered your question as far as adding gadgets. Dennis Vern, welcome to the class. All right, so for my box, my outer dimensions, because of my tissue box and everything, my outer dimensions are going to be 10 inches in length by 5 3/8 inches in height for the side pieces, and 5 1/4 inches in length by 5 3/8 for the height. So we're going to start off with our rectangle tool. We're going to start with our 10 by 5.375, 5 3/8. We'll have this land in the center of our project there. And I'll go ahead and just move this up here for a moment. While I'm in transform mode, by double clicking on an object, I can hold down my control key and I can go ahead and drag down my second part here. Okay, so that's going to be my front and back, basically. Now my two sides, we have 5 1/4 by 5 3/8. And again, double click on it, hold my control key down, I can drag off those two parts. Just move them up here. Let me move this one up a little bit. This one. Alright. Now the top, the lid, is going to be the 10 inches by 5 1/4. Okay. So we're going to go 10, not 510. We're going to go 10 by 5.25. Okay. All right. Now, on the sides of the box, 3 sides, 1, 2, 3, they're going to have 45-degree miters on them. On the 2 end pieces, same thing, 1, 2, 3, they're going to have miters on them. Now, one of these pieces needs to be a 1/2 inch shorter than the other, because there's going to be another 5 1/4 by 1/2 inch part. Oops, not 5 inches, by 1/2 inch, 0.5. That's going to be the bottom piece that's going to be connecting to the bottom panel there that I'm making to slide off. So this one, we need to mill off or trim off a 1/2 inch off of it. So I'm using a guide, and I'm going to right click on that guide, and relative to its position, positive 1/2 inch, I want to create another guide. And that will show me where I need to bring this one up to. Okay. Right clicking on the guides allows me to remove them. And so now here's my parts. The only part that's missing out of this is the bottom panel. The bottom panel, because this project board is all going to be a 1/2 inch thick parts, or 1/4 inch, however you want it. It just depends on how thick you want your walls to be. I'm using, actually I'm going to go 3/8 of an inch thick on these parts. It makes for a nice dainty looking box, not too bulky and things. And so my bottom panel is a 1/4 inch thick, and I'm just going to cut that square panel on my table saw, bandsaw, miter saw, whatever you got. And of course, if you want to do it out of on your CNC, I could always make my project board a little bigger, but it wouldn't be cut out of this. It'd be cut out of a separate project piece. You wouldn't put it in the same job because it's two different size materials. So I'm going to come in here and change my thickness of my material. And I'm going to delete all of these toolpaths because they have no relevance to this. Now, there are two ways that I can make these miters. Number one, I can use my chamfer gadget, or number two, I can use the I can just draw out a vector to where my V-bit is going to cut. Okay, either or. Now, if I were to take my three sides here, if I were to use my chamfer gadget, it's going to put a chamfer on, get my 45-degree angle in there. It's going to put a chamfer on all four sides. Okay, it's going to create a chamfer on all four sides. If we went and looked at this part here, let's kind of zoom in so you can see what this looks like. Now notice the steps, right? The stair steps. Well, don't want that, right? We want a nice clean cut. So when I'm choosing my tool, I need to make sure my step over is very, very small. So generally about like a 2% step over. And when it creates that toolpath, that's what gives it that nice smooth cut, not the stair steps. Now, in the case of this, in this case, sorry about the tone. Someone's texting me during class time, which they should know better. Stand by one moment. So that creates that chamfer, but what it also creates is a very long toolpath, right? So if we look at the time on this to chamfer just this one piece, and also it creates the chamfer on all four sides. How do I prevent that? Well, I would cut the vectors and only choose 3 of the sides, which you'll see in a moment. But the time on that chamfer cut is like freaking 2 hours, right? So it's not practical. It's not practical to do that, but I want you to know that you can do that. I want you to know that you can do that. Now, how do we get it to not chamfer on all 3 sides? Well, we cut the vector, and we only have the sides chosen that we want to use, on that with that gadget, and it will create the toolpath for the just those 3 sides and things. So you can use the chamfer gadget, but it's a very long toolpath. I mean, 1 hour and 35 minutes just to cut that one chamfer. We can achieve the same thing with our 90-degree V-bit. Our 90-degree V-bit has a half angle of 45 degrees, and therefore we can create the path for our 90-degree V-bit, the profile cut for our bit to cut. So in this case, for my 2 sides, all I need to do is actually all 4 parts, I need to just cut the vector to separate that bottom span. Okay. And so I don't have to repeat that part. So I don't have to repeat that process or join things and all. I'm going to take and make a copy of all of my vectors onto a new layer. And this is going to be my profile cut layer. And this layer I'll just rename, since it's already here, to my, we'll call it a miter cut. It's a chamfer, but a miter cut. We'll call it our miter cut layer. And so on the miter cut layer, my 1, 2, 3, 4, 5 parts, and also can't forget the side parts here, right? So we gotta let's take and cut them real quick. This one's actually going to get it on both ends, so all 4 nodes need to be cut to separate those lines. Sorry, my node editing shut down on me, because the 2 edges here get mitered on this smaller piece. So for these parts here, we're going to turn off the bottoms of each of those parts. That is going to be a profile cut. Anytime you are downloading, or I'm sorry, not downloading, anytime you're cutting a profile cut, anytime you're following a line. Sorry, John, yeah, you'll have to get with me later on that. Sorry, I distracted myself. I read the word downloaded. Anytime you're following a line, it's a profile cut. So for this cut now, we are cutting all the way to the depth of that cut. Okay, to our, the outer edge of our part, we're cutting that miter, to the depth. So basically, the depth of cut is going to be 3/8 of an inch. Okay. We're going to be using a 90-degree V-bit. And I want to take past depths of this. Let's see here. 1, 2, 2 passes will be good. We'll do it in 2 passes. And I want to be on the line. Now the lid is getting a profile cut all the way around. It's getting a profile cut all the way around. The miter's on all 4 edges. Okay. So this is going to be our 45-degree miter. Chamfer, miter, same thing. We're going to cut that. And so when we preview that cut, it's going to create this chamfer. But now notice something that happened here. Because my V-bit has a straight lip on it, when I went down to that 3/8 of an inch cut, it created that straight lip. So I have to divide the miters into 2 parts. Because I need this 45-degree angle to continue on. And so that cut depth is 1/8 of an inch. So I've got to step over 1/8 of an inch. My total cut dimension, and this is what I love about the solid view of the toolpaths. Okay, so we can see that cut here. I need to create an offset of these vectors so I can create another toolpath that's going to cut 1/8 of an inch deep. It's because that miter runs all the way from this edge all the way up to the top of the material. So that distance should be roughly 1/4 of an inch. Let me get straightened up here. About 2.459, so we'll call it 1/4. Because the bit is a 1/4 inch wide. So yeah, we'll call it 1/4. So what I need to do is I need to take all of these vectors and I need to offset them inward. Quarter of an inch. Sharp corners. Okay. That's backwards. Alright, we got to do one vector at a time because of my start points. Inward, 1/4 of an inch. These guys are going to be outward. 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 This side on this side here is going to be inward. And this one over here is going to be outward. Need those lines to come in. Okay. So we're creating that point. Now, right here, when I cut in, right here, it created that 1/8 inch lip right there. We can't have that 1/8 of an inch lip. I need it to, cut down to create that miter. So we're going to select these new vectors. And we're going to create another profile toolpath. This time the cut depth is going to be, I want them to overlap. So I'm going to go 0.126, ever so slightly. Maybe I better not do that. Bear with me a second. I'm going to stick to 1/8 of an inch because I need that tip of that bit to be right at that top point. And same bit, same everything, and we're going to calculate that toolpath. Now what this should do for me, if I can spin this part around and get it up to where you guys can see it. What this should do for me is it should clean up those miters to create those 45-degree angle cuts. Okay? Those nice, clean 45-degree angle cuts. Now I need to do my profile cuts, and the profile cuts, we're going to go in, we're going to turn on that layer. And on the profile cuts, we are going to take and join all of these vectors back together. We're going to close them up. Okay? Each one of these we're going to close up. And we're going to select them, and we're going to create our profile cut with our 1/4 inch end mill, 1/8 inch end mill, whatever you want it to be. We're going to go with a 1/4 inch. Will be fine. We're going to be on the outside of the line. Outside of the line. Now the one thing that's important is I probably should have made sure that my parts were at least a 1/4 inch apart, right? We're going to go ahead and calculate that toolpath. Let's see how well we did. I think we did good. And we are going to preview that toolpath. Oh, it would help if I cut all the way through the material, wouldn't it? 0.375. Let's try that one more time. There we go, George. Let's get rid of that. And so now we have our miter cuts on all the size that we need. Now, most important, if we look at this, those two cuts with the V-bit, if we look at our time, 14 minutes. 14 minutes versus an hour and a half for one part, 14 minutes for all of those miter cuts. Followed by the, the profile cut. You're looking at a total of 29 minutes to cut out these parts. Now, the lid needs the hole for the tissue box that we have to cut out before we do the final profile cut. So generally I work with an ellipse for the lid of the boxes, and we will go ahead and get it centered up. And this is just a pocket cut, cutting all the way through the material. I'll use a 1/4 inch end mill, keep things consistent. This is going to be my tissue dispenser opening. Maybe I spelled dispenser wrong, but we'll call it that. So that's going to be my, oval cut for the lid. Now, I've got to create the grooves for my bottom panel. My bottom panel's got to have something to be able to slide into and stuff. So the short part doesn't get a groove because the piece, the small piece actually gets the groove on it. But my other three parts do. And so I'm moving my profile pass down because that's the last thing that we do. But now we got to create our grooves. And so once again, we're going to draw our rectangle. My bottom panel is going to be a 1/4 of an inch. And I'm just drawing out the rectangles right now. I'll size them and all in just a moment. I'm just getting them on the board. Oops. Alright, we'll start up here. So the first thing we're going to do is select our little rectangle that's going to represent our rabbit. We're going to select our part. We're going to open up the alignment tool. We are going to align it centrally and then to the bottom of the part. Same thing here. Select our rectangle that represents our rabbit. Select our part. Align it left to right and then the bottom. One more time. Select the part second. Line it centrally in the bottom. Same thing here. Select this. Align it centrally in the bottom. Now, we'll start here in the corner since we're here. I need my bit to go past the miter, edges, and the bottom. I need my bit to be able to clean up that and give me a nice flat rabbit on the corner. Same thing here. I'm holding the shift key down so I can grab this outside box and it'll size the two ends appropriately. I'm just going past it a little bit, letting go of the shift key and grabbing just the bottom of this line, this rectangle here, and opening that up a little. This one, I'm going to go just a little bit more. I want that bit to get past it just a little bit more, and then opening this up some. Transform mode. Okay, so these vectors are going to represent my rabbit. Okay, and you have to make sure when you're sizing this up so the bit can get past, you still need to make sure that you have your 1/4 inch, because your panel, your bottom panel, is 1/4 inch. Right? So we still need to make sure that, you know, from the bottom of our piece of material to the basically the lip of that rabbit. Oops. Let's go vertical. Got to make sure you have that 1/4 inch. Okay? That's important. Now for those parts, it's our pocket cut. This pocket cut is, my material is 3/8 inch. I usually go half the distance, which is 3/16, which is 0.1875. I'll use my 1/4 inch end mill. Calculate, this is going to be the rabbit cut. Alright, that's going to create the rabbit. The bottom of those parts. Glue these together. All the parts get glued together except for this bottom piece. It only gets glued to the bottom square, you know, 1/4 inch material. But it does not get glued to the rest of the box because that's the little door that opens and closes so you can put your tissue box and everything inside there. Now, I set this up as a single-sided project for just a very basic, simple tissue box. If I were going to carve on the back side of this, maybe something decorative and stuff, then this would be set up as a two-sided job, because then I would be doing some face carving of some decorative pattern or whatever it may be. However I want to decorate my tissue boxes. Tissue box covers, let's call it. And these are wonderful little craft items, by the way, to sell at, you know, just to make and sell. Tissue boxes and all. But when sanded, when glued properly and everything, when sanded, all the edges are nicely sanded and stuff, those those edges just virtually disappear. That wood just wraps around those seams. Those mitered seams just virtually just disappear. It's a really nice, clean looking cut. And so this would be a sample of making a tissue box. Hopefully it wasn't too boring for you. Hopefully it was something you might want to try. You know, and again, you just take your different tissue boxes. There's all different sizes and all. Measure it, and you're giving yourself just a little bit of room, so this thing slips over that box comfortably, and everything, and all. Basically, your inside dimension of the box is the size of the tissue box plus, you know, what? Give yourself maybe a 1/16 of an inch, or 1/8 of an inch, whatever you want to do. You know what I mean? So it's comfortable in there. Now, I'm going to utilize these same vectors and I'm going to bring this box back down because I want all these parts to be the same size. Oops. It helps if you hold your control key down, not your shift key, when you want to make a copy. And the lid, I'm just going to get rid of that for a moment. So we have front and back and two sides of a box. And I'd like to do dovetails, right, on my CNC table. Well, this is where you would definitely have to have the dovetail gadget. I'm working for 2019 for the 2440 units, the way to do dovetails off to the side with the use of a swivel plate, like almost like the 4th axis setup and all. But right now we're working on the flat table. Everybody can do this. Guys and girls that have the desktop software, you don't have access to the dovetail gadgets. So bear with me again while I explain this process. When we're doing the dovetail gadget, Dovetail Creator, we have our pins and our tails, okay, and then we have the toolpaths. Well, on our vectors here, we have to cut them on all 4 points. So we've got to cut the vectors in node editing mode on all 4 points of our part. We have to separate the top and bottom from the side lines. And by the way, you don't have to right click and all. You can put your mouse over the node and hit the letter C on your keyboard, and without having to right click, you can cut the vector by hitting the letter C on your keyboard, and that will do the same thing, other than right clicking. Okay, so now we have our sides, we have our tops and all. And so we've got our pins and our tails. Okay. Generally, you would cut your pins off the side of the box. Bear with me a second. Trying to pull up a picture for you. wood dovetail. Pin and tails. See if I can pull this picture up. Give me a through dovetail, guys and girls. All right, let's pull this over. All right. So you have what's called the tail board and the pin board, right? Generally, your front and back is the tail board, and the side panel is the pin board. When for when those parts get together, and depending on how you look at them, let's see if I can bigger picture and all. The whole thing is joinery. Like if I was doing a dovetail cabinet drawer, right? My tail board would be basically kind of like the front of the drawer, because when I'm pulling on this, I want to be pulling against the joint. I don't want to just rip the front of the cabinet right off. And let me get back to that other picture. And so for our box, the front and the back of the box represents kind of like the sides of the drawer, right? The long length, the sides of the drawer. The pin board is the front and the back of that drawer, the short side, which is the sides of our box. And when those two parts are together, if I were pulling on this front of this drawer and everything, then it's going to be pulling against that joint, and it won't slip off or come off and everything, because as I pull out, it's getting narrower in the back. I don't know if that makes sense, but anyway, so on our project, our tail boards are going to be the two sides, and our pin boards are going to be the front and the back. And so with the dovetail gadget, when we select our parts, we go into the dovetail gadget. We're going to go into what's called the dovetail pin creator. Dovetail pin creator. And here is where you have a choice of making your pins or tails, right? And this is our tail board that we're making, our dovetails. So how many dovetails do we want? I'll go with 3. The width of the dovetails and the depth and the angle, this is the depth and all, that's carried over from the thickness of my material. 3/8 of an inch thick. My material is set up for 3/8 of an inch thick. How wide do I want these 3 pins to be? I'll go 5/8 inch wide. That's fine. And then the angle of the dovetail, do I want it to be a 7-degree angle, 12, 11? I'll stick with the 12 degree. And so we're going to click OK. And that's going to create my pins, my dovetails. But now notice what happened here. Notice at the top, it spun them around backwards, and it brought the part out instead of like the bottom, bringing the part in appropriately like it should have. How do we correct that? Well, it all has to do with our start points. So we're going to undo this. There is no undo button for a gadget. And we're going to redraw our lines. I should have made a copy of this before I did it, but we'll redraw the lines. And I will make another copy on the layers. Okay, and let's go ahead and let me make a copy to a new layer so I don't have to keep redrawing those. Dovetail box vectors, and let me turn that off. Okay, so now if I look at my start points, they should all, because I just redrew these lines. Let's try that again. Don't be a pain in the butt. For some reason, my node button is giving me a hard time. Give me a second, ladies and gentlemen. Node editing. Oh, stop. There we go. Oh no, for a minute there, just node editing was killing me. Okay, so my start point should be basically at the top, right, for all of these parts. Okay, so they're at the top, which means if I select these, whoops, I don't know how that line got in there. If I select these and I go back into that dovetail gadget, dovetail creator, and I've got my dovetails I'm creating and all, and click OK, all of them, my two over here got set properly, but the two out here didn't, which means my start point on the left side needs to be at the top, and on the right side it needs to be at the bottom, because it creates the toolpath in a what looks to be a counterclockwise orientation. Okay, so now I have the ability to come in here, turn on my dovetail jiggers, and copy them to the layer that I'm actually working on. And I need to go in and I need to change the start point for these two on the right side. Okay? Because it's going to create the part in this clockwise motion. Or counterclockwise motion, sorry. Getting my motions mixed up. Alright, one last time. Dovetail creator. Dovetail pin creator, should I say. Dovetail creator. Everything's in here. We're going to click OK. And it's going to bring those in. Now, why does it bring the part in? Because it brings it in the depth of thickness at 3/8 of an inch. Because my box size, I don't want that dimension of my box size to change. So it brings the vectors in. That 3/8 of an inch, because imagine if this was, and let's try to draw an imaginary line here. You know, this was my dovetails, my two parts put together and everything. This is the outer edge of my box. So we want, you know, we want it to bring it in like that. Now what we need to do is we've got to trim off these extended lines. Okay? And so there are our tail boards. Those are our dovetail boards. Now, for our parts here, should have 4 separate lines there. I've got to cut the vectors on this one. And this should be, oops, missed one. There we go. This should be the same situation. My start points should be at the top on this side, and then on the bottom on this side. And if we select those parts, we go back into the Dovetail Creator tool, the pin creator, and this time we're doing our pins. Okay, our pins. And everything else stays defaulted here. It's creating the pins for these. So all we have to do is click OK. And it's going to create those pin toolpaths, or vectors and stuff. Create those pins. All right. Now we're ready to create our dovetails. And so the first thing is we have to create the toolpath, the profile toolpath for the pin boards, but the dovetail toolpaths, they are created by the gadget, the dovetail creator, the dovetail toolpath creator. Okay, they're going to create. Now everything is carried over. Everything is carried over through from the pin and tail creator. So the only thing that I have to do is select my tool, and I'm going to use an 1/8 inch end mill. Whenever I'm doing dovetails, I use an 1/8 inch end mill. And get up to my 1/8 inch end mill. And that's all I've got to do, and this will just be called, dovetail box. And click OK. Oh, I was backwards. Yeah, it creates the dovetails on the pin board. We have to create the profile cuts on the tail board. Sorry, guys, I was backwards. What this does is, let's reset this preview. This creates, I don't know if you can see by the blue. Yeah, you should be able to see. This creates that angled profile, that 12-degree angled cut. So when we preview this toolpath, you'll see these angled kind of chamfered cuts, I guess you would call it, there. All right. And so now, before we need these sharp corners here, right? So we have to create our fillets. It's going to be a dog bone fillet. I'm using an 1/8 inch end mill, so my radius is going to be a 1/16 of an inch. And we're going to, actually, I think I want to use the T-bone fillet for this one. Yeah. Do I want to use the T-bone fillet? Bear with me a second. I believe I do. I believe I do. Yes. T-bone fillet for the dovetails. Oops. I want that fillet to come back into the board. So T-bone fillets. So we need to go through in all the inside corners. On all the tails are going to get the T-bone fillet. And ask questions, guys. I will be answering questions here in just a moment. All right, now we're going to be doing a profile cut, on these parts and everything. We're going to be doing a profile cut. And so when we do that, we need to join these vectors, you know, back together and stuff. Notice that they have these indicator lines here and things. This line is for when I create the final profile cutout. That's why it's, you know, we got to join all these back together and things. But when my router bit is coming, and let's get these, at least these parts joined back together for right now. Get these joined back together. Okay. When my router bit is coming to cut this out and everything, we should not yeah, I'm gonna need to be able to, I'm gonna be required to make my fillet on that side as well too. So let's go into our fillet tool. And I'm going to leave this one undone just to show you what would happen if you don't add the fillet tool. So let's go ahead and create our profile tool path on 1, 2, 3, 4 parts. 3/8 of an inch material thickness. I'm going to use my 1/8 inch end mill. 1/8 inch end mill. I'm not going to have tabs on here. I want to be able to, you would add tabs normally, but I'm not going to add tabs. I want to be able to, you know, show this profile cut and everything. So let's calculate this tool path. And I want to try to focus on this tailboard here. On both of these. Bear with me a moment. Okay, so let's preview. Okay, now let's take a look in solid view. Okay. Now, on our cutouts, the pin side and everything, using the dog bone fillet creates that lip here. And that distance is that 3/8. Coming here, this creates that radius. Well, let's go back and look at our dovetail cuts and look what our dovetail cuts have done for us. So they've milled the material back this far on those angles. So therefore, we don't need the dog bone fillet because it's already, you know, created that relief. So the only thing we need the dog bone fillets on are just the tail side, not the pin side. So that means I can come back into my fillet tool and I can get rid of, because you can see that it's cleared away where that radius is going to be just by the when it did the angle cuts. And if I look at the 3D view, getting rid of my waste material, let me turn off the toolpath here. Yeah. See, it creates that nice, clean, almost flush cut with just a little bit of a back cut. We don't need that in there. Wonderful. So then we're going to just recalculate the toolpath. So we only put the dog bone fillet on the tail side. We don't need it on the pin side because the toolpath, this dovetail box toolpath here, when it creates them, it gets rid of that radius and gives us that nice flat internal area in there. Okay, and that would be our dovetail box. We can just snap it together. We still got to put our dados and grooves and stuff like that if we were putting the bottom of the box on or what have you, but at least you get the general idea. Let's see if I can zoom this in. There we go. All right, and so you understand the dovetail. This angle cut here, that 12-degree angle cut on the tail, the pin side, that matches this 12-degree angle on the tail side. When these are in a 90-degree orientation, it creates that angle cut and everything. So that's what the dovetail gadget does for us. It allows us to carve dovetail boxes on a flat table surface without the use of a dovetail bit, just using a regular straight end mill. Dennis says, can I ask what the runtime would be for something like that? I'm a big fan of using all the tools in the shop and wonder if it would be faster to profile cut it and do the rest on the table saw. It's absolutely going to be faster, Dennis, but on the tissue box, I'm assuming that's when you asked that question. The tissue box preview. On the tissue box, the total run time 35 minutes. 35 minutes. And so the biggest part of that 35 minutes is the profile cut, cutting the part out. Now, if I was using a small enough bit, I could start my profile cut a little bit lower than 0 because this miter, this 90-degree miter, has already been milled away all the way down to the bottom. So I could, start that cut at 1/4 of an inch in and reduce that time. Let me see if I can show that. Bear with me a second. Let's turn the profile cut off. Okay, so from 0, the top of my board, I've already got all this material milled away until, right about the end. And my bit is cutting on that right side of this kind of, I don't know if you can see this line right here and that V. So I've got a good 1/8 of an inch or so that I can go down. I can start my toolpath at that. So I don't have to start at 0. I could, you know, point 2, you know, and calculate that toolpath. And let's actually, oh, did I delete all the vectors? I did. Dadgummit. Dadgum, I used the same vectors, Dennis, to create my dovetail. Alright, let's see here. Wait a minute. Let me turn something off here. Let me join all these back together. Alright, and then I believe my lid was 10 by 5.375. And then I believe I had an oval. All right. So if I started that profile cut, then it's, you know, 0.2 inches down, and calculate. Oops. Then I would only need to go 0.175 further than that for cutout. My box lid is going to be funky because the vector isn't in the right orientation. But preview that toolpath. They're all going to be off. But that time, that 14 minutes, would be reduced down to 8 minutes. So bringing the whole project to about 30-minute runtime. You know, and you can cut those 45-degree angles on those pieces on your table saw in a quarter of a time, you know, safely. So, you know, and you just, you know, your fence changes, you know, from the different sizes, the two sizes, but you could cut that out with the table saw. And then if that was the case, the whole thing other than the top of the part would be cut on the table saw. Turn it over and do some decorative carving on the other side, then cut your miters and stuff on it with your table saw. Now as far as the dovetail box, 34 minutes to dovetail that box out, with the majority being the, again, the profile cut. You know, 22 minutes on that profile cut, which of course could be increased by limiting the pass depths and so on and so forth. So box making, whether you're using a gadget or drawing yourself, now unfortunately it's hard to do the dovetails on the flat table without the gadget, simply for the pinboard side. Those angle cuts 12-degree angles and things like that. Now I could try to use like the fluting toolpath, but it doesn't give me an angle. It doesn't give me an option to do an angle, so I can't use that. I could come in if I had a 12-degree V-bit, and I could do a V-cut on those 4 parts, and cut that out one way. But the dovetail gadget is going to be kind of the way to go. And for you guys that don't have access to gadgets because you have the desktop software of the Vectric, there would just have to be some workarounds that you would have to try to come up with on that. Debbie says, so does that leave a visible gap where the T-bone billets are, so you can see the space in the holes? Yes, it does. Cutting dovetails on a CNC, bear with me, CNC dovetail box. Let me bring it over. You do see those openings where where those are. Now, if you cut dovetails on your CNC using a jig, off of the side of the table or something like that, then you can, you won't see any of that. But this is what it actually looks like up close, Debbie. You can see the small little, you can see the small little pinholes, and then right underneath you can see all the little gaps. And that's using an 1/8 inch end mill. That's why I don't use a 1/4 inch end mill or anything big like that. Very small bit, because the gap is very small. Nothing that is going to be unsightly. It looks fine. Hell, you could use a little putty filler if you want to. If you wanted to hide them. But if you use a big bit, a big diameter bit, then you're going to have, those bigger gaps and bigger holes and stuff. So, where would it be? Where would it be? So, like finger joints and all, big bit, big radiuses out there and all, you'll see those dog bone and those T-bone fillets and stuff. But a small radius bit, you're pretty much not seeing very much of it at all. That's why I recommend or prefer small radius bits. 1/8 inch, would be about what I cut with. Ronnie Probert, what would you sell this for at the craft shows? What, my tissue boxes? My long rectangular tissue boxes. Let me switch over to my camera so you can see me. Where we go? There's 3 different size tissue boxes. So we have our kind of fat, long rectangular tissue box. You've got the smaller, narrower box, and then you have kind of the rectangular box. Okay, what we just made, the box that we just made was for the wider rectangular box, that 4 3/8 by 9 1/4, inside dimensions and stuff. If you're ever curious about dimensions of a box, inner dimension, just measure and give yourself about a 1/16 of an inch. But as far as price, so my box covers will range from, because they're usually in something like a really nice wood, spalted maple, a apple wood, cherry, zebra wood, you know, something decorative and all. And a rectangular box is $30 for the cover. The two rectangular sizes, not much of a dollar difference between them. They're pretty much the they're in the $45. The long story short, $45 range. On the smaller box, I could give someone a $5 discount and go $40. But depending on the three, they're ranging from $30 to $45 for the covers. Now, if we went online and wooden tissue box covers. Wooden tissue box covers on Amazon range from $4 to $14, things like that. That's what you're competing with. So you need to be able to justify $35 and $45 and things like that. And I use exotic woods. I'm not using pines or basswood or oaks or anything like that. I'm using tiger maple. I'm using zebra wood, apple wood, and all. Tissue boxes, you just have to understand that you're competing with Etsy. Like an Etsy, here's $50. This is a beech, walnut, oak, cherry box, or I guess you have the choices of beech, walnut, oak, or cherry, $50. And that's going to be more our range. But these little pine boxes and stuff that you can get at Hobby Lobbies and stuff like that, you got to be better than that, to be able to sell. But you're in the range of $30 to $45. And they, tissue boxes come in all different looks, shapes, sizes. You can get really decorative with them, with doing some carvings on them. Nice decorative inlay work, right? Mitered splines, inlay, V-carve, all kinds of different decorative options and stuff. And so you can really just let your imagination go, have fun with it. Different themes and all. Or you can go with the plain box, the plain boxes and stuff. Just very simple, plain boxes. This is zebra wood here. This is zebra wood there. You can do contrasting materials, right? Glue up your panel before you cut it out. And you could do contrasting materials and stuff, accent stripes. A lot of wonderful, wonderful examples of things. Here's a very cool one. The only thing is the CNC can't do undercutting, right? Can't do undercutting to get that inside cut, that book look. So the CNC, you would have to cut it in sections and then glue those sections together, because you couldn't cut it out as a whole, part. But you've got your side pieces, your front panel, your back panel, all of that's laying flat, so there is no undercutting, so you can actually create something like this. That'd be very cool. Lot of cool different things, so, but $30 to $45 range is where my boxes are. Where'd y'all go? Oh, there you are. Okay, so Bob Hill, how does the bottom hold into the box? It slides. Okay, so let's go back to our Etsy here, or not our Etsy, our SketchUp. All right, let me draw this out appropriately. Bear with me. Where's my move button? Let me move this out of the way a minute. Stand by a second, guys. Get my box back together. Forgot to make this part unique, so therefore it created those two separate parts. All right. Oops. Dadgummit. Okay, so Bob, there is a groove in the box. It would help if I open up the panel. Bear with me a second while I draw this out. Oh, come on there, Haas. Oh, Lord. Stand by a minute there, Bob. Gotta make it unique. Just wanting to work on the other side as I'm working on this one. Alright, so there are grooves all across the sides and the back panel as well. And this part, let's see if I can get both of these to work with me. This part slides into those grooves. Bear with me a second. Let me select them again. The bottom of the box, when you pull on the door, there's a panel that slides in and it's a groove. There's a rabbet in there that allows that part to slide in and lock in. I don't know if that answers your question or not, but there's rabbets. Groove. It's a groove, actually. It's not a rabbet because you can't see it from the bottom. They're inside that panel. So there's rabbets along the sides and the back. With me? Get it? Got it? You can't see. Oh. Are y'all still looking at my ugly face? How funny is that? Sorry. That whole time, y'all didn't see none of that? Alright. There is... Sorry, Bob. Sitting there watching me draw. I didn't realize I was still on me. There is a groove on the two sides and the front, back, and the one side over there. There's a groove that the panel slides in and everything. And you can't see the groove from the bottom. It's a groove. It's not a rabbet. You know, so there's a groove in there. the panel slides in. Like drawer slides, but it's a groove cut in there. Alright. I showed you. Sorry about that. Y'all were looking at my ugly mug instead of what I was drawing. Okie dokie. Alright. Now, some box covers just have the front, back, and the two sides and the top, and there is no bottom. It just drops right over the box, the tissue box. That's fine. I like having the bottom on there because I like to be able to, like, if I'm taking that tissue box with me somewhere, I don't want to have to sit there and hold the bottom. You know what I mean? But some people just, it's a cover, you know, just a slip-on cover. You know, the box is sitting on the kitchen counter, bathroom counter, whatever, you know, nightstand, whatever, and it drops right over it, right? Just it's a cover. I prefer the enclosure where it has a bottom panel and everything. So, yeah. Yeah, Ronnie, good tip, right? There, Ronnie said if there was a hole at the bottom, if there was a hole in the bottom of sorts, like almost like a finger hole, then you know, someone could grab that, you know, finger hole and oops, you know, slide it open that way, you know. Yep. You could put a little divot here at the end, you know, like a little finger grab, you know, all kinds of things you can do. Good tip, Robert. Yes, Dennis. Nice seller for office people. You can do their, you know, their company logo on it or what have you. But just general, you know, just home, you know, home use. You know, people love decorating their home with some really nice stuff, and the tissue box is the most unsightly thing around. You know, you could do all kinds of cool things with it. Toilet paper dispensers, tissue boxes, and all. But this is a topic of box making. So, but any questions? Now, who was it? Are you in the class? Hopefully you're in the class. Who was it that asked initially for the box making class? Box making class. Are you still with me? Let me know who that was. The original post in the Facebook group saying, hey, I'd love to see a box making class. Who was that? Raise your hand. Robert says you could also put felt on the bottom so it doesn't scratch the surface. Yep, cork, felt, however you want to do it. For sure. Yep. All kinds of nice things. Well, the long story short was, did this class give you guys a decent idea about making boxes, or was it not helpful at all? Let me know. All right. One thing I do want to talk about is when we are doing two-sided machining and you flip your board over, one of the most useful ways of doing it is, in your top part, is to mill your alignment pin holes partially through the material. You know, let's say if this was a 3/4 inch board, 3/8 of an inch, right? Partially through. And then you're going to have those alignment holes. You're going to mirror them on the other side of the project. And when you're going to create a toolpath for them, and what that will allow you to do is, and let me mirror these. Let me copy these guys to the other side. What that allows for is I can sit there and on my top side create my tool path for my alignment pin holes cutting 3/8 of an inch deep, you know, off of my current XY position of, you know, the bottom left corner, blah, blah, blah. And I can mill that. Now, something comes up. I got to go somewhere. I got to leave. I come back that evening and I'm like, oh, you know, I don't want to finish this up, but someone, you know, where I went, you know, someone had a really urgent order or whatever the case may be, and I needed to mill something else. Well, I can take this board right off the table. I can throw my next project board on the table. I can rechange my zeros and all that stuff and, you know, carve that other project. And then it's like, okay, oh, I want to get back to my box. I want to finish it off. Well, I can zero out my machine anywhere that I want to zero it out. And I can touch off on my Z on my waste board. And I can run the toolpath for the holes for the bottom side because they're going to be cut, you know, about 1/4 of an inch deep, but they're going to be cut on my waste board. And I can cut them anywhere on my waste board because when I take now and create that toolpath, I cut in my waste board, put my pins in, I can now take that project board over and flip it over and drop it down on those alignment pins. And off of that current zero that I set up to, you know, cut the alignment pins in the waste board, I'm basically working off that. And now I can touch off on my waste board, you know, because that's why I got it set up in the job setup for that double-sided job to touch off the same surface, you know, off the waste board. This would be, you know, that second one. And so I can just drop this down on those pins and I can carve and everything's going to be in alignment. It doesn't have to be at the same time. I don't have to cut the front and the back at the same time in the same session. You know, I can do it days apart, weeks apart, whatever, for whatever reason. If I mill all the way through my board and into my waste board with my alignment holes, then those alignment holes in that table are off that current Z or XY position. And therefore, I have to run them in the same session. I have to cut the top, flip it over, put it on the pins, cut the bottom in the same session. Because it would be unless I could precisely and accurately re-zero out my X and Y back to where I was if I did this a day later, you know. So the option that I'm saying is when you're doing a two-sided job, and you don't have to have consecutive, I don't have to have my holes, you know, perfectly centered and side by side. I could have a hole here and here, you know, and these could be my two alignment holes. And when I copy that to the other side, that hole, and when I flip to the other side, you know, it's mirrored, right? That's what I'm going to be creating my toolpath on. But my alignment pins, if I cut halfway through the board and then cut the mirrored toolpath in my waste board, I could do that at any point in time. I don't have to run it in the same session. But if I cut all the way through my board and into my waste board to create my alignment pin holes, then I have to carve the front and the back in the same session because I'm working off that original XY point. Partial cut through with two separate toolpaths, one for the board, one for the waste board, allows me to the freedom to you know, not have to run everything in the same job, same day. I don't know if that makes sense, but I highly recommend that you create your alignment pin holes. You cut partially through the board for your first toolpath for your alignment pins, and then when you mirror this over to the back side and you select your two vectors for that mirrored toolpath, you're going to be setting that drilling operation, pocket cut, whatever it may be, to just a small amount because it's cutting from the waste board. you know, and because one alignment pin hole toolpath is going to be cutting from touching off on the top of the board, the other alignment pin toolpath is going to be touching off on your waste board. Okay, so two separate toolpaths, one for your project board cutting partially through, one for your waste board cutting to whatever depth you want to cut into your waste board, 1/4 of an inch, whatever maybe, and that gives you the freedom of being able to carve those sides on different days, different times. It doesn't have to be the same XY setup, all of that stuff. So keep that in mind. All right, so let's see here. Alan Feldman was the one wanting the class. Okay, Alan, hopefully you're still here because this class was for you, right? And everybody else too, but Alan was the one that requested it. Thanks for that. But hopefully the whole purpose of asking that initial question of who did it was, Alan, you brought up this class topic for a reason. Did we cover the things that you want to cover? Was there anything that you were looking to learn from this box making course that didn't get covered? Let me know. Let's see here. John McMillan, thank you very much. John, get with me. I'll work with you on the gadget. Ronnie, thank you. Robert, when you originally did the rabbit cut, you did it on the bottom, not a 1/4 inch up from the bottom. On the rabbit cut, okay, Robert, you're absolutely correct. So what Robert caught was I created, instead of a drawer slide, I just created a rabbit cut in the bottom of the part rather than having it up a little bit. And so, therefore, let's see if I can kind of get back to on those parts. Let me get rid of, bear with me a second. Try this one more time. On those rabbits, I showed you guys I'm making a rabbit at the bottom of the material rather than a groove. So generally, we would have some material underneath that creates like a slide. Now, Robert, it doesn't have to be a 1/4 inch up. It can be whatever, whatever depth it is. But on that rabbit cut, preview the visible toolpaths. It creates that lip that holds the bottom piece in when the door is shut. The rabbit that I had made before, if that bottom panel was not glued in permanently, it would just fall out, right? It'd be redundant. So you want to have some meat material or that groove cut for the bottom part to slide into. That basically creates that like Jora slide, you know, that slide, so you can slide it in and out in between this groove. Your panel fits in there. Good catch, Robert. Bob. All right. So do you guys understand that? Give yourself a little bit of meat. Put your vectors slightly up some, whatever distance you want. Make sure it's a consistent distance on all, you know, all 4 parts. So if I were doing this consistently, I would come in here and I'd make another guide. So that's actually 1/8 of an inch up. Let me make sure. Let's go 0.125. Yeah. So wherever, 1/8 inch, 3/16, but make it consistent. So if I'm going 3/16, then my ditto groove is going to fall, you know, on that 3/16, and you want to make it consistent, you know, 3/16 on all the parts. 3/16 up. So if I move this relative to its position on the y-axis, 0.1875, you know, make sure it's consistent all the way around, you know, for all three of the rabbits. One of them doesn't get a rabbit. Okay. On the small part, if I have a 1/2 inch, imagine my 1/2 inch piece, right? Let's imagine this is the lid right here, and I've got my 1/2 inch part, and it goes to the bottom of the material. Then my rabbit cut, so that back bottom panel can fit in there, is going to be, you know, wherever it falls on that 1/2 inch part. In this case, it falls you know, 40 thousandths of an inch. Not practical. So I would have this part let me close that tool. I would have this part flush with that. I would create the rabbit out of there, and it would be glued together like so, so that these two parts would, you know, slide in and out as one, you know, when they're glued together. So if they were glued together, they would more likely look like something like that. So when that part slides in and out, you know, of those grooves, so you got to figure out where you're going to be as far as your positioning, and then that small piece that creates the handle, you know, you need to know where that dado's got to get cut on it. Okay, guys and girls. Well, everything looks like I'm looking to see if I missed any questions. There you go. All right, guys and girls, looks like there's no other questions. Let's see if I can end this on a not quite on, but anyway, if y'all have any questions. Thickness of the box, the tissue box is you can use 1/2 inch material, 1/4 inch material. 1/4 inch material makes for a nice, thin, dainty box. Really lightweight, you know. If you're going to do anything, you know, kind of V carving or something decorative in it, then 3/8 or 1/2 inch. In my case, what we drew tonight is 3/8 inch. I like a 3/8 inch box thickness, material thickness, 3/8 of an inch. All right, guys, y'all have a wonderful evening, and hopefully this was informative. But start making some boxes, start drawing out your parts, and think about your joinery. Hell, you could just do some decorative V carving on some square pieces. Take those square parts over to your table saw, miter cut them, and put your miter box together. I don't know if you guys and girls have ever checked it out, but on YouTube, if you haven't looked it up, I'd be surprised. But if you go to Vectric.com, or not Vectric.com, what am I saying? Vectric, and on YouTube, they have a wonderful channel of videos and tutorials and things. All kinds of different stuff. All kinds of creative things. Different types of projects and all. And this video here, making a box by Michael Tyler's, this is just a very simple mitered box where the parts are cut out and V carved and all, and then you take it over to a table saw and cut your miters and stuff in it and everything. But there's some wonderful projects and things on the Vectric YouTube channel. Tutorials and stuff just like in the tutorial library, but they do have users come in and make videos and stuff, and also definitely check that out sometime. All right, boys and girls, until next time, thank you for joining me. Wait, hold on a second. Still a little confused on the locate pins. Halfway through, Wayne. Real quick, guys, let me just do this real quick. Okay, Wayne, imagine I have a board here. This is the top of my board. First thing I'm going to do is I'm going to create my toolpaths for my alignment pin holes. And in this case, they're 1/4 inch holes. So I'm going to be using a 1/4 inch end mill. And I'm going to cut halfway through my material. My material thickness for this project is a 1/2 inch thick. So I'm going to be cutting a 1/4 inch deep with my 1/4 inch end mill. Let me find a 1/4 inch end mill. Okay. Now, I'm going to take those two vectors and let me calculate this toolpath. There we go. That's going to be my regular pinholes in my board, cutting halfway through my board, touching off on the top of the board, carving the top, just like everything, you know, that was done. All my little decorative holes and stuff. Now, I'm going to take those two holes. They could be positioned anywhere, really. They don't even need to be positioned on the ends. And I'm going to right click and copy them to the other side. Okay, that mirrors them. So imagine if, you know, when this board's flipped over, it's putting those holes in the proper orientation on the other side. So when I flip this board over, now I've got my two alignment holes. Now these holes, I'm not cutting into the board. These get cut into the wasteboard. I'm just using the placement of the vectors for the placement of my holes. So I'm going to be drilling probably a 1/4 of an inch into my wasteboard. So set up. All right. Now, the first set of toolpaths from the top of my board, those get cut off. Those get cut into the top of my board. When I'm set my X, Y, and Z for the bottom left, I've got my board clamped down. I'm going to be drilling all my little decorative holes and then my 2 alignment pin holes. Okay. Now I move that board. I unclamp it, move it completely out of the way. Gone. Move it out of the way. Now I'm going to touch off my Z. If I'm doing this in one session, I'm going to touch off my Z in my 1/4 inch end mill. I'm going to touch it off on my wasteboard. 0. The top of my wasteboard is 0. Okay. And I'm going to run that second set of alignment pin holes. That's get cuts in my wasteboard. Okay. And now I flip my board over, I put my little pins in, I flip my board over and slide it over to those pins and everything's in alignment. Well, by having this second toolpath that I'm carving in my wasteboard, that means that I can carve those 2 holes anytime I want. I could change my X and Y 0 position. I could do, at the other end of the table, what have you. I could 0 out my X and Y, and I could drill those 2 holes using this toolpath, touch off to my wasteboard and touch it off. And then when I take my board and grab it off of my workbench, and I take my board and I flip it over and I slide it onto those holes, now when I start to carve and everything is off that new position. Everything that's on the back side is on that new position, and it's all going to be carved in the proper place. Because I would have more than just 2 holes on the back side. There would be something on this back side, some dados or joints or what have you. So if you cut all the way halfway through and then set another toolpath for your wasteboard, then you're not restricted to having to do everything all in one run. If you cut all the way through your board and into your wasteboard for your alignment pin holes, now you're working off that current X and Y that you're zeroed out on, that you're working on. And there's no room for error. If you try to do it a day later, you better get right back on that X and Y position exactly where you were. Okay? Hopefully that made sense. All right, ladies and gentlemen, y'all have a wonderful night. Until next time, I'll see you soon. And John McMillan, give me a call if you need to.